Welcome to the Connect with Truesight webinar series. During today's event, you'll be able to ask questions of our panelists. The questions and answers will be posted along with this broadcast to the YouTube channel a week from today's date. Today's topic is TSSA, Smart Agent Best Practices and Troubleshooting, and Shreya will take us through this content. Over to you, Shreya.
Thank you, Greg, and hello everyone. I am Shreya Kapse, working as Staff Technical Support Analyst in BMC's Truesight Server Automation Support. In this webinar, we will talk about Smart Hub, Smart Agent, their installation and configuration, and troubleshooting. So let's see what a Truesight Server Automation Smart Agent and Smart Hub is. Truesight Server Automation Smart Agents and Smart Hubs were introduced in TSSA 2002 GA version. TSSA performs all the tasks on the target servers through the RACD agent installed on these target servers. The RACD agents perform the tasks as directed by the application server. Smart Agent is an add-on feature of the RACD agent which is installed on the same host as that of the RACD agent, that is on the target servers. Smart Agent generates enrollment and RACD agent's heartbeat requests, that is the status of the RACD agent. The Smart Agent communicates with the TSSA application server via the Smart Hub. All the requests and responses that the Smart Agent generates or fetches are stored in the Smart Hub. That takes us to the Truesight Server Automation's next component, that is Smart Hub. Smart Hub is an additional component that acts as a medium of communication between the application server and the Smart Agent. Smart Hubs manages the work requests and responses from the application server as well as the Smart Agents. It also acts as a CA and handles the authentication of the clients. You can configure multiple Smart Hubs in a single TSSA environment, but one Smart Agent can only be managed by a single Smart Hub. There is an additional and optional component of Smart Hub called as the Smart Hub Gateway. Smart Hub also acts as the medium of communication between the application server and the Smart Agents. The difference here is that these Smart Agents are installed in a virtual private cloud servers. Let's see what are the benefits of Smart Agents. Smart Agent lets you enroll the new target servers in the TSSA application server as soon as the Smart Agent service on these target servers is up, which reduces the overhead of enrolling these new target servers manually in TSSA once the RACD agent is installed. RACD agent status is continuously monitored by the Smart Agent, and if it detects any change in the status of the RACD agent, it will automatically reflect it in TSSA. Along with the RACD status, Smart Agent can also monitor the defined server properties, and if it detects any change in these server properties, it will get automatically reflected in TSSA. Smart Agent can also help in pushing the predefined agent configuration files on all the target servers, hence ensuring a consistency of the ACL files on all these target servers. Let's see how the Smart Agent and Smart Hub fits in the TSSA architecture. Here you can see there is a push and pull service in the config instance of the application server, which helps to manage the work requests and responses from the Smart Hub on port 443 and Smart Hub Gateway on 1080. On the other side, we have a target server where the RACD agent and the Smart Agent service is installed. The Smart Agent service also connects to the Smart Hub on port 443 and the Smart Hub Gateway service on 1080. The Smart Agent service will share the request to the Smart Hub. The Smart Hub will store all these requests in its database, and then the application server push-pull service will pull these requests from the Smart Hub DB to update it in the application server. This completes the architecture. Now let's move to the demo part. This demo is for installing the Smart Hub. There are two ways you can install the Smart Hub. First is using the installation script, and second is installing it silently. In this demo, I have opted for installing the Smart Hub using the installation script. These are the supported platforms for Smart Hub installation for TSSA version 2102. For the demonstration, I am using Red Hat 7 server. Log into the server where you want to install the Smart Hub using root user and go to the directory where you have already downloaded the installation files. Extract the downloaded zip file. There will be two directories generated, SmartHub and SmartHub Gateway. Go to the SmartHub directory and run the setup.sh script. Read the license agreement and type Y to accept the license. Enter the directory where you want to install the SmartHub, else just press enter to use the default installation directory. Enter the port you want to use for SmartHub. Default port is 443. Enter the shared secret key to be used for the SmartHub. This shared secret key is used for authentication between the application server and the SmartHub. Enter the shared secret key again. Redis server is used as a database for SmartHub, so you can provide your existing Redis server or use the one that is bundled with the SmartHub installer. If you use the packaged Redis server, then the default port is 6379. Enter the password for the Redis server. Confirm the password. Provide these details to create the CA certificates. Provide these details for generating the SmartHub server certificate. Provide a password to be sent along with the certificate and an optional company name. The SmartHub has been installed successfully. We will see the Truesight SmartHub Gateway installation later. You can use the systemctl status command to check the SmartHub service if it is running or not. Now let's see how to register the SmartHub in the application server after its installation. Log into your application server console, go to Configuration, Infrastructure Management, right-click on the SmartHubs, New SmartHub, provide the name of the SmartHub, provide the host name of the SmartHub, validate the port number, provide the polling interval in minutes. This value determines the time after which the application server will poll the SmartHub to fetch the information. The default polling interval is 5 minutes and you can set it till 60 minutes. I will set it to 1 minute for the demo. Connection timeout. This is the period up to which the application server will wait to connect to SmartHub before timing out. Shared secret key. This is the key used for authenticating with the SmartHub. You have to specify the same shared secret key that you have used while installing the SmartHub. User and role. This user and role will be used to manage the target servers which are enrolled by the Smart Agent. So I will provide BL admin and the role is BL admins. Make sure that the user and role that you are providing is available in the application server. Server group. You can create or select a static group in which the new enrolled servers will be added. So I am using SmartHub enrolled server static group over here. Proxy server. This is an optional parameter and will be used only if there is a SOX proxy server between the application server and the SmartHub. I will click on next. The SmartHub gateway configuration we will see later. Click on finish and your SmartHub is registered in the application server. Let's see how to install and configure Smart Hub Gateway. You can install the Smart Hub Gateway during the installation of the Smart Hub itself. But if you have the Smart Hub installed and you want to install the Smart Hub Gateway later, that can also be done. So let's see how you can install the Smart Hub Gateway after you have already installed the Smart Hub. I will go to my Smart Hub server, check the Smart Hub service using systemctl status Smart Hub service command. The Smart Hub service is active and running. So to install the Smart Hub Gateway now, go to the directory where you have placed the installers. pwd here. I'm under data folder. If I do lsf and lrt, I can see a Smart Hub Gateway directory that gets generated when you unzip the Smart Hub installer. So I will go to the Smart Hub Gateway, lsf and lrt. I will execute this setup.sh here. It has started the installation of Smart Hub Gateway. The installer first will request you to accept the license agreement. So press enter to continue, read the license agreement and then press yes to accept the license. Provide the Smart Hub Gateway installation. The default directory is /opt/bmc for Linux. I'll enter so that it will use the default location for installation. You can provide a custom port for Smart Hub Gateway. I will use the default port, that is 1080. I'll hit enter. Provide the Smart Hub host. It's the same host that I am installing the Smart Hub Gateway on. So I'll just use the default one, smarthub.bmc.com. I'll hit enter. Enter the port where the Smart Hub is listening. So my Smart Hub's port is default, that is 443. I'll hit enter. You have to provide the shared secret key that you had provided during the installation of the Smart Hub. The installation is done. It is starting the service now. So the installation of Smart Hub Gateway is completed. To start, stop or check the status of the Smart Hub Gateway, you can use these systemctl commands. So I will check the status of the Smart Hub service now using this systemctl command. It says that the Smart Hub Gateway service is active and running. Now let's see how to configure the Smart Hub Gateway in TSSA after its installation. I will go to my TSSA console, in Configuration, Infrastructure Management, expand the Smart Hub. This is the Smart Hub that I have used. I'll right click on it, Properties, go to Smart Hub Gateway and click on Yes. That is if the Smart Hub Gateway is configured. So right now we have configured the Smart Hub Gateway. That's why we are clicking on Yes. I'll click OK. Click on the Smart Hub. Here you can see Smart Hub Gateway is enabled, yes, and all the details of the Smart Hub Gateway. To update the status of the Smart Hub Gateway from unknown, right click on the Smart Hub, click on Update Smart Hub Status. Now the status of the Smart Hub Gateway is changed to running. So this is how you can install and configure the Smart Hub Gateway service. Now let's see the features of the Smart Agent in detail. There are 4 features of the Smart Agent as of TSSA 2102 version: auto-enrollment of new agents, auto-update of agent status, auto-update of the server properties, and agent configuration policies. The first feature that we will discuss is the auto-enrollment of new agents. Target servers in an on-premise or cloud environments can be auto-enrolled in TSSA using the Smart Agent. The requirement for having the servers auto-enrolled in TSSA is that you should have the RCD agent with the Smart Agent installed and configured on the target server, and the Smart Agent service should be first started. Let's see the workflow to understand the tasks performed during the auto-enrollment process. As soon as the Smart Agent service is started, Smart Agent sends an authentication request to the Smart Hub. Smart Hub acts as a CA and sends the client certificates back to the Smart Agent. This authenticates the server. Once the server is authenticated, Smart Agent sends an enrollment request to the Smart Hub. Smart Hub then receives this request and generates an enrollment ID for the specific target, and it stores this enrollment request. As per the polling interval, the application server then polls this request from the Smart Hub. It gets its response, and once the server is enrolled, the application server sends the enrollment response back to the Smart Hub, and the RCD agent is enrolled. Once done, the Smart Hub then stores this enrollment response received from the application server. Smart Agent then pulls the enrollment request from the Smart Hub. Smart Hub shares this enrollment response to the Smart Agent. At the end of this workflow, the server is registered. Moving on to the second feature of the Smart Agent, that is the auto update of agent status. As we discussed, the Smart Agent keeps monitoring the status of the RACD agent on the target server, and if it detects any change in its status, it will get reflected in the TSSA in the server property agent underscore status as shown on the screen. Let's see the workflow of the auto update of agent status feature. Once the Smart Agent is running, it detects the status of the RACD agent on the target server and it will send the heartbeat request to the Smart Hub. This heartbeat request will contain the status of the RACD agent and its timestamp. Smart Hub verifies if the RACD status of the server has changed or not, and as per that, it will store the heartbeat request in its database. The application server will poll for this request and process it. If there is any change detected in the RACD agent status, the application server will update it in it. Let's proceed with the demos of installing, upgrading, and troubleshooting the Smart Agent. These are the supported platforms for the Smart Agent as of TSSA version 2102. Smart Agent is bundled with the RACD agent, so when you install the RACD agent, the Smart Agent as well gets installed. But the Smart Agent will be in disabled mode unless we specify to enable it. This demo is for how to install the Smart Agent silently on a Windows server. First, copy the RACD installer on the target server. Open a command prompt from the directory where the installer is placed. This is the agent installation command that we will use. Now let's look at the properties that we have for Smart Agent installation. This document is for silent mode installation of agent on Windows. Scroll down to look at the Smart Agent properties. Smart Hub hostname. You have to provide the hostname of the Smart Hub that you want to use to enroll the server in TSSA. Next is the Smart Hub port. This is the port that you have used to configure the Smart Hub. The default port is 443. Enroll interval minute. Once the Smart Agent is installed on the server, this is the time taken by the Smart Agent to send the enrollment request to the Smart Hub. Enroll as. This is the value with which the server will be enrolled in the TSSA. As you can see, you can enroll the server with its hostname or its IP address or its FQDN name or its UUID. This UUID is available for the public cloud servers. You can also use the conversion operator upper or lower along with the predefined identifiers to change their casing, that is the value of the target that gets enrolled in TSSA. For the demo, I will be using the identifier hostname along with the conversion operator upper, so that when the target server gets enrolled in TSSA, its value will be something like this, that the hostname will be in uppercase. Heartbeat interval minute. This is the time frame after which the Smart Agent will send the heartbeat updates to the Smart Hub for its status. Smart Agent service. Once the Smart Agent is installed and configured, the value of this parameter will determine if the Smart Agent service will be enabled or not. The default value of this parameter is 1, that is, the Smart Agent service will be running after its installation. Access key. Once you register the Smart Hub in the application server, there is an access key generated. You have to provide this access key in the Smart Agent configuration for its connection with the Smart Hub. We will see how to fetch this access key in a bit. There are few more properties that we will see as and when we proceed with the demos. Coming back to the demo, these are the Smart Agent properties that I am using for its installation. Now let's see from where we can get the access key. Go to your application server, configuration, infrastructure management, Smart Hubs, right click on the Smart Hub and select show access key. Copy this access key. Go back to the Windows target server and provide the access key here. I will copy the command, go to the command prompt and execute it. This will start the RACD agent and the Smart Agent installation. Now, once the installation is done, we will go to the control panel and validate the same. As you can see, Truesight Server Automation RCD agent of version 2102 has been installed on the server. Now let's go to the services and check if the RCD and the Smart Agent services are running or not. So as we can see, this RCD agent service is running and the Smart Agent service is running as well. I have provided the value of enroll interval minute equals 2 minutes. So once the Smart Agent is running, after 2 minutes, it will send the enrollment request of the server to the Smart Hub. And once that request is completed, I should be able to see this target server in the TSSA console. Now let's see if the Smart Agent has sent this enrollment request to the Smart Hub or not. We will go to the smartagent.log that resides under Program Files BMC Software BladeLogic RSCD folder. Open the log file. Here we can see that the Smart Agent has started and it has sent the server enrollment request to the Smart Hub. Now we will scroll down a bit to see if the enrollment request was successful or not. So as we can see, the Smart Agent has received a successful server enrolled code and the server has been enrolled in the application server with the name Windows Target 1. This is because of the enroll as Smart Agent property that we used with the hostname as the identifier and upper as the conversion operator. And we can see that the Smart Agent has started providing the heartbeat request of the RCD agent to the Smart Hub. Now let's go to the TSSA console and check if the server is listed here or not. We will go to servers, the Smart Hub enrolled server static group that we have provided, and we can see that the target server has been enrolled or registered in the application server. So this is how you can install the agent and the Smart Agent silently on any Windows server. This demo is for how to upgrade the Smart Agent on a Linux server using the agent install or upgrade job. As you can see on the screen, I have a Linux server and its agent version is 8904.227. Now let's see how to create an agent upgrade job to upgrade the RCD agent to 2102 version. An agent install or upgrade job requires agent bundle with the agent installer of the specific OS type. Now, since this server is a Linux 64-bit server, I will go to Depot, BMC Maintenance, Agent Installers, 2102 Installers, and open Linux 64. These are the out-of-the-box provided installers. There are some changes that we need to do in the RCD installer for installing the Smart Agent. Scroll down and you will see the NSH install defaults parameter that expects a file named NSH install defaults as its value. This file contains the same Smart Agent properties that we had seen during the Windows installation. I have already created this file, so let me go to the server where I have stored the file. So these are the parameters and their values that I will be using. Smart Hub hostname and the hostname of the Smart Hub port, the enrollment interval minute, the access key, the heartbeat interval minute. I will go to my console, file location, go to the server where you have stored the NSH file, temp, NSH install defaults, select OK, click OK and save the installer. Now we will create a bundle that uses this installer. I will close this, go to agent bundle, new agent bundle, provide a name, next. I will use the default values, so select next, provide the agent installer. So platform here will be Linux 64 and the agent installer location. Agent installer 2102 Linux. Click OK. Next. So this will give you the summary of whatever you have selected in the agent bundle. Click next, next and finish. I will go to agent bundles directory and validate if the agent bundle that I have created is visible. I will use this bundle to create an agent upgrade job. Install agent, provide a name, provide a folder name where you want to save this job. Click on Next. Here you can select the operation type if you want to only install, to only upgrade, or install upgrade depending on the current state of the agent. I will select install upgrade. Click Next. Select the server where you want to upgrade the agent. Click Next. I will execute this job now. Finish. I will go to the directory where the job is stored. BMC maintenance agent installer job 2102 smart agent job. Show results. The job is in progress. Once the job is finished, we will go to the server. I will refresh it. Click on the server and check the agent version. As you can see, the agent version has been upgraded to 2102. Yeah, so these are the Smart Agent server properties that will be available once you install the Smart Agent or upgrade the RCD agent to 2102. Here you can see that the Smart Agent status is unknown and there is no Smart Hub name. This is because when you upgrade the RCD agent, it will install the Smart Agent, but it will not start the service of the Smart Agent unless and until specified. To specify the status of the Smart Agent service after upgrade, you can use the Smart Agent underscore service property value to set as 1 in the NSH install defaults file during the upgrade job execution. If I want to start the Smart Agent service, I will go to the target server. I am in the directory /etc/init.d. I will do lsf and lrt. There is a Smart Agent binary available here along with the RCD agent binary. I will execute Smart Agent status. So the Smart Agent service is stopped. In order to start it, Smart Agent start. To check the Smart Agent service status, type Smart Agent status again and the Smart Agent service is running. Once the Smart Agent is up and running, it will send the heartbeat request of the server to the Smart Hub and the application server will pull these requests from the Smart Hub. And you can see the Smart Agent properties getting populated. So now the Smart Agent status is alive. The Smart Hub name is also available. So this concludes the agent upgrade scenario. Now let's see how to enable the debug mode for Smart Agent logging. Same as the RCD agent, to enable the debug mode for Smart Agent, we need to update the log4crc.txt file, which is located as per the path shown on the screen. To enable the debug mode, I will go to /etc/rsc and look for the file log4crc.txt. I will open it and look for Smart Agent entry. This is the priority with which the logs are getting generated right now, and this is the path for the smartagent.log. To update the priority, I will replace info with debug. Close the file and restart the Smart Agent. I will tail the log file of the Smart Agent to check if the changes have been reflected. Now I can see debug logs getting generated as well. The next demo is for troubleshooting the Smart Agent related issues. Let's look into the scenario where Smart Agent is installed on the server, but the target server is not auto-enrolled in TSSA. For example, I have a Linux target server that I want to auto-enroll in TSSA and I have installed the Smart Agent on the same. But even after successful installation of the Smart Agent, I don't see that server in the TSSA console. So in such scenario, the first thing I will validate is that if the Smart Agent service is running or not. As you can see, the Smart Agent is active and running. The next thing to check is what is getting logged in the smartagent.log file. So I will go to the Smart Agent log file folder and try to see if I can get any hint in the file. So here I can see that the authentication of the Smart Agent is failing with the error could not resolve hostname and the Smart Hub hostname. So I will check if the target is able to resolve this hostname or not. So I can see it is not able to resolve the hostname. Now I can see that there is an extra M in the name of my Smart Hub, which is why the target is not able to resolve the Smart Hub. All the Smart Agent config related details are stored in a file smartagent.conf, which resides in the RSC folder. Smartagent.conf is the file that we can validate or make any changes for Smart Agent related configs after its installation. This file consists of the Smart Agent properties that we had seen during the installation. So here we can see that the hostname of the Smart Hub, port of the Smart Hub, the access key that is being used, what is the state of the enrollment of the server. Since the server has not been enrolled yet, the state of the server is new. What is the server name, server GUID, and all the other Smart Agent related configurations. As we can see, the name of my Smart Hub in this configuration file is incorrect, so I will update it, save the file, and restart the Smart Agent service. Once the Smart Agent is started, I will validate the smartagent.log, as I can see that the server enrollment was a success and it has been enrolled with the name linuxtarget2.bmc.com. I can also see that the Smart Agent has started sending heartbeat request of the RSCD agent to the Smart Hub. I will go to the console, refresh the static group, and check if the Linux server is available or not. So as we can see that the target server is enrolled now. So if there is any Smart Agent related issue, below are the log file that you can check for the exact error message. Next feature of the Smart Agent is auto update of server properties or auto USB. This feature is released from TSSA 2102. When a target server is enrolled in the application server, it retrieves its intrinsic and uneditable properties such as operating system, OS version, and so on. These property values may get changed over the period of time due to the various tasks performed on the target servers. To ensure that all the server property values are up to date, a manual execution of the update server properties job has to be done. The Auto USB feature automates the task of keeping the server properties up to date and hence eliminates the manual overhead of scheduling and running the USB jobs. The Smart Agent compares the previously saved server properties with the newly computed server property values. If it detects any change in these server properties, Smart Agent will send the newly computed server property values to the Smart Hub, and the application server will pull these details from the Smart Hub and then reflect it in the application server. By default, the Auto USB feature is enabled when you install and configure the Smart Agent. If you want to disable the Auto USB feature during installation, you can provide the value of Auto USB enabled property equals to false. You can also update the interval in which the Auto USB job will execute using the Auto USB interval h property. By default, the property value is 2 hours. We have documented the list of server properties that are managed by the Auto USB feature. Now let's see the Auto USB workflow. Smart Agent detects the server property values of the target server and creates an Auto USB work request. As per the interval set, Smart Agent then sends this information or the work request to the Smart Hub. Smart Hub processes the details and stores the updated server properties. The application server will pull these work requests from the Smart Hub and get its response. Once the server property update response is received, the application server updates the server property values in it. Once done, the application server will share the status of the work request and the Smart Hub will store this response to share it with the Smart Agent. So these are the tasks performed during the Auto USB workflow. Moving on with the demo on how to enable the Auto USB feature if during installation of the Smart Agent this feature was disabled by the user. I have a Windows target server auto-enrolled by the Smart Agent service. The property Smart Agent Auto USB timestamp for this Windows server is set to blank. That means the Auto USB has not updated the application server about the server properties of this target server. This is because the Auto USB feature of the Smart Agent on this target server is not enabled. So let's see how to enable the Auto USB feature of the Smart Agent after its installation. I will go to the target server and open the smartagent.conf file, as all the Smart Agent related configurations are stored in this file. I will open this, scroll a bit, You can see the auto update server properties section in this file. It is set to false currently, so to enable it, I will set it to true and save the file. Once the file is saved, I will go to the services section and restart the Smart Agent service. I will go to the RCD folder to check the smartagent.log for the auto USB related logs. Here you can see that it says auto update server properties is enabled. The current auto USB interval set is 2 hours. You can change the auto USB interval in the same smartagent.conf file. You just have to put the value in hours for auto USB underscore h here. You can see that the auto USB has sent a work request to the application server with all the details of the server properties. I will go to the console, refresh the static group, click on the target server and check if the Smart Agent Auto USB property reports the timestamp when the Auto USB was enabled or not. So here you can see that Smart Agent executed the Auto USB on this time. So this is how you can configure Auto USB after the installation of the Smart Agent. Moving on to the next demo in Auto USB is how the Auto USB would work or what is expected from Auto USB. I have a Windows target server where the RCD version is 2102 GA. And the last time that Smart Agent Auto USB had detected any change in the properties which it supports was on 8th of June. So after 8th of June, there has been no change in the Auto USB supported properties. So RCD version is one of the supported properties by the Auto USB feature of Smart Agent. So if there is any change in the version of the RCD agent, the Auto USB should automatically detect it. I will go ahead and upgrade the RCD agent on this Windows target server. For the demo purpose, I have already upgraded the Windows RCD agent to 2102 patch 1. So if the Auto USB is enabled on the Smart Agent of the target server, it will detect the change in the RCD version and it will update the application server that the RCD version has been changed, as you can see here. Now the Smart Agent Auto USB timestamp has been changed. You can also get this information what has changed in the application server logs as on the screen. So here I can see that the server property change has been detected for the server Windows Target 1 and the property name, what was its previous version and what is its new version. So the value of RACD underscore version previously was 2102 GA and now it is 2102 patch 1. So this is how Auto USB will detect any change in the supported server properties and update it in the application server. Let's see the fourth feature of the Smart Agent, that is the agent configuration policies. TSSA performs any tasks on the target server through the RACD agent. The access of TSSA to the RACD agent is managed by the agent configuration files, that is exports, users and users.local, which is present on the target server. The administrators need to manage these ACL files and perform a periodic check on them to ensure that the ACL files are correctly configured before executing any jobs on the target servers. The agent configuration policies feature of the Smart Agent automates the task of managing these ACL files on the target servers. An agent configuration policy is a collection of the configurations defined for the exports, users and users.local file. The policy will also have rules where you can mention on which target servers the policy should be applicable. Once the agent configuration policy is configured and applied to the target servers, the Smart Agent periodically monitors the policy status, and if it detects any changes in the applied configuration policy, it will alarm the application server. If there is a change in the configuration policy, the Smart Agent will receive the updated configuration from the application server and the new policy gets applied to the target servers. This ensures that consistent configurations are applied across all the target servers. The prerequisite for agent configuration policy is that your RACD version on the target server should be 2102 and above, and the Smart Agent should be enabled on the target server. Let's check the workflow for this feature of the Smart Agent. The agent policy is created on the application server end. It will send the copy of the policy to the Smart Hub. The Smart Hub will store this policy in its database. Smart Agent scans for the policy for any changes that the application server may have shared. The smart agent then updates the ACL on the target server if there is any change detected in the agent policy. Once done, the smart agent will share the response with the smart hub, and the smart hub stores this response. The application server will then pull this response from the smart hub and updates the response in the application server end. Now let's proceed with the demos of how to set up the agent configuration policy and its troubleshooting. Moving on to the demo of how agent config policies can be set in TSSA. To create the agent policies, I will go to my TSSA console. There is a new node named agent policies which will contain all the agent configuration policies that will be created. I will right click on agent policies, create a new folder. I will go to that folder, right click and create a new agent configuration policy. I will provide a name to this policy. Click next. You can control the permissions on these agent configuration policies in this step. Click on finish. Once done, we can go to configurations tab. So as you can see, these three are the files that agent config policy will be managing. So by default, this is in disable mode. We can enable it if we want. We can define these files for each OS type, that is Windows or Linux. If I want to update the exports file of a Linux server, I will enable it. This is the path where the exports file is stored. This is the mode or the permission with which the file will be created or updated. So for traditional RACD agent, the file will be created with 600 permission, and for the servers that have RACD plus NSH, the most common example is repeaters, the exports file will be created with the permission 644. So I will select RACD only. These are the non-editable parameters, owner and group of the file, and this text box is for the file contents. So for the demo, I will be adding this star entry for Linux servers. I will go to users.local file for Linux, enable it and update the file contents here. I will put bladmins entry. I will go to the users file for Linux, enable this. As you can see, there is no file content text box over here since the users file contains the ACL of the target server that depends on the target server permissions for the roles and users which are computed by the configured ACLs. So when you will push the config policy on the target server, the details of the users file will be same as the ACL push job. Next is to define the scope of the policy. This means on which target server the config policy should get executed. The rules can be defined here. Target name contains bmc.com. So when we click on evaluate, it will show you all the servers that match this condition and if the agent config policy can be executed on these servers or not. So there are two prerequisites for the agent config policy to be executed on any server. The agent version should be minimum of 2102 and the smart agent should be enabled on that server. So here as you can see on this file server, the smart agent is not enabled. So hence the agent configuration policy is not supported on this server. I will now save this config policy and go to the location where it is stored. So here you can see a blank icon in front of the agent config policy since this is a fresh policy and that has not been executed as of now. I will close this and apply the policy. So here you can see that the icon has been changed. That means the policy has been applied. To check the results of the config policy, we can open it and go to the results tab. To get the result of each server, we can click on this run and check the results for the servers. Here you can see on these two target servers, the agent config policy is successful, but on this server it is not. This is because on this server, as we had seen, there was no smart agent installed. Now to validate if the agent config is set on these servers or not, I will go to one of the target servers. I am under RAC folder and I will check the exports file. I can see that the value of exports file that I have provided is updated. I will cat the users.local file as well. So here also I can see that bladmins and bladmin entry is present. I will validate the users file as well. So here I can see the ACLs that are computed on this particular target server. From the console, you can validate which config policy is applied on the server. So here on this particular Linux server, I can see that the agent config policies has the value of the agent config policy 1 that I have created. You can define multiple config policies, but a target server cannot have more than one config policies on it. If there are more than one config policies for a target server, this property will show us a conflict over here in the value section. An example can be seen in this document. So here you can see in the agent config policies, it reflects a conflict and gives us the name of the policy that are conflicting. So this is how you can create a config policy in TSSA 2102. Let's see how to troubleshoot agent config policy related issues. I will go to my application server console. I have an agent config policy 1. I will double click it. In the policy scope, I have provided target name that contains Windows as its name. So if I evaluate it, I will get the list of target servers that will be impacted with this agent config policies. If you click on the agent config policy, go to properties. In the extended properties, you can see interval hour. So this is the time after which the agent config policy will be executed on the target servers that are eligible. The default time is 2 hours. You can edit it if you want. In case you do not want to execute this agent config policy, you can keep the value to 0. I will keep it default here. Go to my agent config policy and apply it. I can see that it is in task in progress. I will open this agent config policy again. Go to results tab and check the status. Here I can see that the agent config policy is failed. So I will right click on this, do a show log, go to error, Windows. Here I can see the message that configuration policy does not have any configuration policy enabled for Windows operating system. This means that there are no configuration files to be applied on the Windows operating system. So I will go to my configuration policy in the configuration tab, click on exports. Here I can see for Windows, this agent config policy is not enabled anywhere. So which is why the agent config policy is failed. So I will enable it for Windows, edit the file content here. I will provide read write user equals administrator and save the agent config policy. Once done, I will apply it again. Once the job is finished, I will go to results, refresh this. Here I can see that the agent config policy is a success. To validate if the config policies have been applied on the target server, I will go to my target server under C Windows RSC. I'll refresh this and then check the exports file that I had provided in the config policy. Here I can see that the exports file has not been updated by the config policy. To troubleshoot why, I will go to my console. I'll close this, go to my target server, properties, and get the GUID of the target server. So this GUID will be assigned to each target server when the server is registered and will be unique. With this GUID copied, I will go to my application server and cat the app server Smart Hub logs to see if the agent config request has been polled by the Smart Hub or not. So here I can see that the config policy message has been received by the Smart Hub. So I will check the app server log to see if I can get anything with this GUID. In the application server log, I can see that it has updated the configuration policy status for this policy and the server. This is the GUID of this target server from apply request sent to apply failed. This means that the agent config policy request that had been sent by the application server has been failed on the target server. So we will go to the target server to know more. I have now logged into the target server. I will go to RSCD location and search for the smartagent.log. I'll open the smartagent.log. Here I'll scroll down and search for any configuration policy logs. There is an error reported in the smartagent.log that the configuration policy apply has been failed. Smart Agent configuration policy feature is disabled on this server. The details of all the Smart Agent related configurations are stored in the smartagent.conf file. So I will go to RSC folder, open the smartagent.conf file. In the configuration policy section, I can see that the config policy enabled is set to false, which is why the config policy could not be applied on this target server. So I will set it to true, save this file, go to the services section and restart the Smart Agent service. Once the Smart Agent service is restarted, I will go to the RSC location, refresh this and check the smartagent.conf file again. Here I can see that the configuration is set true. I will go to my console, scroll up and apply the agent config policy again. It is running. Once done, I will refresh this and here I can see policy is a success. To validate this again, I will go to my target server under RSC folder and open the exports file, because this is the file that I had provided in the agent config policy. So it says that it has been modified. So I will reload this, click on yes, and now I can see that the agent config policy is updated and I can see the administrator user being mapped in the exports file. This concludes the demo of agent config policy troubleshooting. In the references, we have some of the documents related to Smart Agent and Smart Hub. Also a blog that covers the details around the Smart Agent and Smart Hub topic. I hope you find this webinar helpful. To summarize, we talked about the overview of the Smart Agent and Smart Hub, where it fits in the TSSA architecture, how to install and upgrade the Smart Agent related configuration and logs, and the features of the Smart Agents. This concludes my presentation, and now I will hand it over to Greg.
Thank you. And now I'll take us through the self-help in contacting BMC. The YouTube channel where this webinar will be posted is available at this link. It contains past webinars as well as a rich set of how-to videos. The Connect with Truesight webinar schedule that contains future webinars as well as our past webinars is available at this communities link. Also, the Hot Off the Press newsletter contains trending information. And to contact technical support via web, phone, email, as well as these social channels are available through these links. That will conclude our session today. Thank you for attending.